Okay, so this is the beginning of section 2.7, and it talks about 4 different concepts that actually have the same meaning mathematically. We're going to talk about tangent and velocity and derivative and instantaneous rate of change. So the first two are problems that we have seen in the past. What if I have a particular function and I'm going to only focus on one point. I'm going to call it a f of a. And I want to say, okay, I'm going to draw the tangent line. And what would be the slope of this tangent line? And ultimately, what would be the equation of a tangent line to that point? So the idea was, if I want to approximate this, and if I had values around, I can take the slope of secant lines on both sides and then take the average of those secant lines and approximate the tangent line that way. The same idea with velocity. How do I make this a velocity problem? Well, if I have this graph where the x-axis represented time and the y-axis represented distance, then the idea is the same. What is the velocity at this particular point? What is the velocity if at 3 seconds, for example, and that will be again the slope of this tangent line. These two concepts in mathematics are equivalent to the concept of derivative. If this had no meaning, if this was simply x and f of x, and I have any function and I'm looking at one particular point, I'm going to be talking about the derivative of that function at that particular point and how much it's worth. And again, the same idea here. I have a tangent line. The slope of this tangent line is the value of my derivative. And for instantaneous rate of change, I think this is something that we have seen before as well, and it has to do with velocity. The instantaneous rate of change, if I have time and I have distance and I have a function, I want to know how much is the change in x, how much is the change in y respect to the change in x, and as the change in x becomes very, very small. So again, the idea is we have a tangent line and I need to find what the slope is. All these questions are very interesting because we want to know, for example, let's compare two functions, y equals e to the x and y equals x squared. Remember, these are the parent functions. The most important point for e to the x is the point 0, 1. For y equals x squared, you know what the pattern is. You go over 1 up 1, you go over 2 up 4, and so on. So how do you notice for x greater than 0? How can you describe the function? Well, I can say that both of them are increasing. And that's a fact. If I move my finger along the curve, I notice that as x grows, y grows, and the same happens here. But which one grows faster? So I have to have a mathematical way of actually describing how fast a function grows, how fast the y changes respect to the x. So that's why we have the concept of derivative, to describe how much a function is changing in respect to x. And that's all there is to it. So as you are going to start your reading about 2.7, just think about those 4 concepts being equivalent and actually using the same mathematical concept of derivative. So after you're done with the reading, I can explain how these 4 things look like. For example, one, let's say